debugging Apache Spark, because nothing is as easy as it seems. So what are we going to cover in the next 10 minutes? We'll start with a brief overview of Nielsen's data architecture and how Spark was a core component in it. We'll then talk about how we used to access our Spark logs and why that was just not good enough. A deep dive into the solution we provided for Spark log accessibility, some main obstacles, because every solution has to have an obstacle, some pretty Kibana charts, and some future and add-ons to top it all up. But first, the most important thing, which is who am I? So who am I? I'm Simona. I'm a big data engineer at ADOC. I've been dealing with data for 10 years now, which feels like a lot. I'm 29 years old. I love music, especially Australian one. I love Japan and I love traveling. So this is basically me in a picture. Let's start. So I think the first thing that really pops into your eyes when you look at this architecture is Spark. There are more than 50 terabytes of data, billions of events flowing into this architecture daily, and they get deserialized, enriched, aggregated, and eventually stored in each one of the several different data stores, all done by Spark. And at the time we were running Spark, and what was, or maybe still is, one of the most popular platforms to run Spark on, which is Amazon EMR. And so a big part of your job as a data engineer at Nielsen would be developing and maintaining these big, robust Spark jobs and applications. And so I want to start our discussion off with when we need to access Spark logs. And you need to access Spark logs in one of two cases. So the first one would be when you launch a new Spark application and you probably want to follow it up. And the second one would be when you have a production issue and you might know that the problem is with Spark or you don't, but you want to access the logs and see what happens. And so time is an essence in both of these cases. And so now that we have that in mind, let's look at how we used to access logs. And so the first way that would be most straightforward when you run your Spark on Amazon EMR would be just SSHing directly to the EC2 servers that are running Spark on. And so after you SSH into the server, you actually have to find the relevant folder where Spark logs are stored, and then you have to find the relevant file, right? Because we have several components, we have tasks, we have our driver, and each one of them is outputting to a different log file. So you have to find the relevant log file that you're looking for. You have to find the relevant EC2 server containing that relevant log file, decompress it, access it, and then start searching your log file. And that would take quite a lot of time. So you do have a centralized way to see all of your Spark logs, and that would be just accessing your log files through the Yarn UI. You can just choose your favorite web browser and go there. But the problem with that would be the fact that probably when you want to access your logs, your Spark application was already running for quite a while, and the log files aggregated, they get quite big. And so you try and access your logs through the Yarn UI, and then your web browser tries to load them up and just crashes and dies. And so you go to the third way that's possible for accessing your logs, and that's just downloading them straight from S3. So Amazon do provide you with that possibility. They migrate the log files from the EC2 servers to S3, but there's quite a lag between the moment that the logs are actually written to a file and the moment that they get migrated to S3. And because we said that time is an essence, and all of these ways we're wasting our time, we wanted to provide a solution that would make Spark log accessibility just really, really easy and really, really quick. And that's why we built a solution based on the ELK stack. And so the really core component, the star of this architecture, is Beats. And so for those of you who are not familiar with Beats, Beats are lightweight shippers provided by Elastic, developed by the community. And each one of these shippers is dedicated to collecting a different type of log data. And so we've used two of them. We've used the Filebeat for collecting Spark log files, log data. And then we also used MetricBeat for collecting the EC2 metrics, the metrics of the EC2 server, because we're already there, so why not? So we're installing Filebeat and MetricBeat on each one of the EC2 servers on our cluster. We will do that using Bootstrap Actions. After that, the data gets gets shipped off to Redis. From there, we have several log/files, log/servers. So the log/servers, they do consume the data off of Redis. They eventually ship it off to Elasticsearch, and then you can access your logs and visualize them using Kibana. So let's deep dive. So the first thing that we're going to do is just briefly discuss Bootstrap Actions. For those of you who are not familiar with them, you can just use Bootstrap Actions in order to install additional software on your EC2 servers, on your EMR. And so what you see before your eyes is just the documentation taken from Amazon's website. And so if we look at the Bootstrap actions that we've configured, we can see that we've configured one for MetricBeat and one for Filebeat. And what it essentially does, it just runs a bash script that we've developed that receives some configuration parameters. And that bash script, that's what's really interesting. So the first thing that we have to do when we install Filebeat is just see that we're running on an EC2 server that is not the master, right? The reason for that is that Spark is not running on the master node on your EMR. Luckily for us, that information is stored on each one of the EC2 servers by Amazon, so that's not a problem. The second thing that we're gonna do is just, well, if it's not the master, we're gonna install Filebeat. We're gonna receive some configuration parameters, and we have two types here. The first type I call for the future, because we're gonna use this information, we're gonna use the information we receive from these variables in order to make our logs more searchable. And that is everything that can pop up in your mind. So that would be flow name, right? The application is probably part of a flow. That would be team name, anything that would make them more searchable. And the second type of configuration parameters that exists for historical reasons. So what does that mean? At Nielsen Israel, we had one data team that grew up to be 3 data teams. In each one of those 3 data teams, they use a different log4j file for their Spark application. So a different log4j file, a different log name, a different name for your log file, a different regular expression for your logs. And really forcing engineers to work in a standardized way, that sometimes can be really, really hard. So we said, that's fine. You don't have to change your log4j files. Just, we will provide you with the possibility to configure your Filebeat in order that you would still be able to collect that log information. And we'll see how we made that work in just a second. But first, what we're gonna do is we're gonna wait for Java to be installed on the server. The reason for that is simple. Filebeat and MetricBeat, they both need Java as a prerequisite. And since Bootstrap Actions run before software gets installed on the servers, there's still no Java there. So the bash script starts running and we say, hey, halt, wait for Java to be installed. After that, the path is clear. We download the RPM file straight from the Elastic website and we install it. And now what we have to do is just configure our Filebeat to collect the relevant log files. And so I think most, if not all, Elastic products, they just get configured using YAML files. And so that also includes beats. So we're going to configure our YAML file for Filebeat. And the way that we're going to use that is simple. So we've created a Filebeat YAML template file that we can just edit from within our script using Z. And for this reason, we have all of these configuration parameters. So we're going to add the tags that we've discussed earlier, right? The flow name, the team name. And now we can actually also use a regular expression that we've received from the engineers in order to tell Filebeat how to collect the logs, how the logs look like. And so if you look at the YAML file, at the template YAML file that we've created, you can see that under the multi-line pattern, we're just providing them with a regular expression pattern that the engineers provided us with. And the second thing, which is a bit interesting, is also the EMR cluster ID. I think EMR cluster ID can really provide you with a better way to search your logs, right? Because a lot of the times you just launch a new application using a new EMR, and that's information that you have for the run that you actually want to look at. So just keeping in mind for the future, we also created the EMR cluster ID field. By the way, we could just provide that information still, since the EMR cluster ID is actually stored as well on the EC2 servers. We're going to install MetricBeat in the exact same way, nothing new here. And that's actually it. It's a really, really simple solution. It's a really simple architecture. So what would be the obstacle here? So the main obstacle we encountered was just data engineers, because I think data engineers, they suffer from the same problems as a lot of other engineers. They would go, you provide us with a new solution? Nah, all is good. We like ssh-ing into our EC2 servers. What we have to configure for this to work? Bootstrap Actions? Nah, changes work. But we overcame that obstacle. We convinced them to do it, and now everyone's working with it. So some pretty Kibana charts. The first chart is just like the amount of logs that had warning and the amount of logs that had error in their log level. And that's nice. I really think that just like visualizing your logs with different charts, that's really cool. That's really nice. But this is the star for me. So what you see before you is the actual log that we've collected. And if I can draw your attention to the message field, the message field, that's the actual log line, right? That's what we were aiming to achieve. Everything else is a bonus. We have tags here that include the flow name, that include the team name, right? Everything that would make searching logs easier. We have the EMR cluster ID that we discussed a bit earlier. Some information about Yarn. So we have a lot of extra information, and all of that extra information just makes searching logs a lot easier and saves you quite a lot of time. So what's in store for the future? The first thing that we do is actually just replace Redis in this architecture with Kafka. The reason for that is very simple. As you connect more and more applications to this architecture and get more and more data with higher arrival rates, Redis just becomes not enough. It becomes an actual bottleneck in this architecture. And so we really think that just like replacing Redis with Kafka that is more robust would just serve this architecture a lot better. And then the second point is the fact that we're collecting log files essentially from EC2 servers that are running together as EMR. And we had at Nielsen quite a lot of services like Druid and Kafka that we were running on EC2 servers. So you can just implement the solution on any EC2 servers based service. Thank you so much for joining my session. I really hope it was useful and that you enjoyed it, and just that it would make your log search a lot more fun and a lot more quick. Thank you.